For the forecasting, sequential forecasting offers hundreds of thousands of points. Let's first review standard perception and prediction pipeline, which consists of object detection, multi-object tracking, multi-agent trajectory forecasting. In this work, we wonder if this pipeline is the best choice, and if there are any limitations in this pipeline. While there can be many, we focus on the limitation on the labeling requirement. To train modern 3D detector, this standard pipeline requires instance-level object annotations, for example 3D bounding boxes. Also, to train 3D MOD and trajectory forecasting methods, sequence-level object annotations are required. This means that the annotator needs to ensure correspondences of object annotations through time, which is more expensive to obtain than the instance-level annotations. In this work, we propose a novel perception and prediction pipeline that inverts the order of forecasting in the standard pipeline. Compared to the standard pipeline, our new pipeline can largely reduce the labeling requirement. In the meantime, to support our new pipeline, we also propose a new task, which we call Sequential Point Cloud Forecasting, abbreviated as SPF. Now let's take a look at our new pipeline, which we call SPF squared. Specifically, instead of running detection, tracking, and forecasting, our new pipeline first forecasts point clouds, then we perform detection and tracking on the forecasted future point clouds to obtain future object trajectories. The difference between our pipeline and conventional pipelines are twofold. First, our pipeline inverts the order of forecasting. Second, the forecasting in our pipeline is at the sensor level because we forecast the point cloud data captured by the LiDAR sensor. Okay, we have talked about the differences. Is there any advantage of our pipeline? First, the FPF in our pipeline does not require any human annotation because the ground truth can be just point cloud data. Moreover, because there are strong common filter-based 3D MOT methods which do not require training, we can use them in our pipeline and reduce the labeling requirements to instance-level object labels. In other words, we only need to train 3D detector now, and sequence-level object labels are not required anymore, which significantly reduces the labeling requirements. Now let's focus on the first step in the pipeline, sequential point cloud forecasting. We already know that this new task does not require human annotation for training, which is good. What else do we know about this new task? Well, one other benefit is that the prediction of our SPF task represents the entire scene, which includes important information about both the foreground objects and background scene. Our next contribution is an effective approach for the proposed SPF task, which we call the SPF net. Here is an overview of our SPF net, which contains 4 modules. 1. A shared point cloud encoder that is used to extract features from past point clouds. 2. An LSTM network to model temporal dynamics of extracted features. 3. A shared point cloud decoder that generates the point cloud in the future. 4. The chamfer distance noise is applied to the predicted and ground truth future point clouds for the training purpose. Okay, let's talk about the results. The first question is that, is our SPF net effective to the SPF task? To answer that question, we devised a few baselines for comparison. For example, directly copy point clouds from the past, or using ego motion estimation, or using point cloud alignment techniques to propagate point clouds to the future. Lastly, we use one scene flow method to compute the pointwise motion and propagate it to the future. From the results, we can see that our method with 2 different encoder-decoders performed the best, which is reasonable because only our method is designed for non-horizon prediction. Next, we evaluate our new perception and prediction pipeline, which uses the SPF net as one component for the first step. We compare our new SPF squared pipeline with the conventional pipeline, and we can see from the results that our new pipeline is competitive to the conventional pipeline using various trajectory forecasting methods. Thank you for watching.